Okay, we are at Unit 1, Lesson 3, solving right triangles. Solving right triangles means that you're going to calculate all the lengths of the sides and all of the angles that are unknown. To solve a right triangle, we have the following tools available to us. We have Pythagorean theorem. And you know from previous lessons that you use Pythagorean theorem to calculate a side when you know two of the sides in a right angle triangle. In addition to Pythagorean theorem, we've also been working on SOHCAHTOA, which is also known as right angle trig. SOHCAHTOA allows you to calculate a couple of things. Using SOHCAHTOA, you can calculate a side length when you know an angle and a side. Or you can calculate an angle when you know two sides of a right angle triangle. And in addition to Pythagorean theorem and SOHCAHTOA, we have one other thing we think way back that we should know about angles. We should know something about the angle sum of a triangle. That being that all the angles add up to 180 degrees. A right angle triangle is a special case of this. In a right angle triangle, one angle is 90 degrees. If one angle is 90 degrees, then the other two angles must add up to 90 degrees, because 90 plus 90 equals 180. So we have these three things to figure out all the unknown lengths and all the unknown angles in each right angle triangle. Pythagorean theorem for lengths, angle sum of the triangle, knowing they add up to 180 for angles, and SOHCAHTOA can calculate either a length or an angle depending on the information you're given. So let's look at an example. When I look at an example, I examine the picture first and I decide what information I've been given. So I've been given an angle and I've been given a side length, specifically the side length of the hypotenuse, because I know it's across from the right angle. If I look at my list of three things I have to solve the triangle, one of them says when you know an angle and a side. In A, I know an angle and a side, so I should be using SOHCAHTOA. So I'm going to use SOHCAHTOA to start with. In order to use SOHCAHTOA, I need to decide whether I'm going to do sine, cos, or tan. So in this question, I need to decide what side I want to figure out. I could figure out side B or side C. Remember, we name sides based on the angles across for them. So as this is angle B, then this is side B. And if this is angle C, then this is side C. So they're labeled with the small letters of the angle across from them. So I think I'm going to start by figuring out side B. So if I want to figure out side B, and the angle I'm given is 35 degrees, side B is opposite to 35 degrees. So when looking at SOHCAHTOA, opposite and hypotenuse is sine. So I want to use the sine trig function. So I'll fill in my formula. The sine of 35 degrees equals the opposite side, B, over the hypotenuse, 12.5. And then I use what I know about trig to solve. Instead of dividing by 12.5, I bring it over here and I multiply 12.5 times the sine of 35. It's going to be the length of B. Let me get out my calculator, make sure it's in degree mode, and I use my calculator. 12.5 times the sine of 35. And I get approximately, well, I didn't say in my question, but we can round to 1 decimal, approximately 7.2 meters. So that's the length of one side, but remember, solving means to find the lengths of all the sides and the sizes of all the unknown angles. So if I want to figure out side C, I can use trigonometry again, or since I now know two sides, I could use Pythagorean theorem. I'm going to stick to trig because I'm going to try to use only the numbers I was given in the question rather than a number that I calculated myself in case I made a mistake in my calculating. I'm going to try to use the numbers that were given to me in the question. So the numbers that were given to the question is the angle 35 and the 12.5. And I want to figure out the other side, C. So to angle 35, side C is adjacent, and 12.5 is hypotenuse. So adjacent and hypotenuse are cosine. So I have the cos of 35 degrees equals the adjacent C over the hypotenuse, 12.5. And I continue on the same way I was doing before. 12.5 times the cos of 35 equals side C. I get out my calculator and I figure out my side length. 12.5 times 35 is about 10.2 meters. So same as before, I have got all three side lengths, and I know angle A is 90, and I know angle B is 35. Now I need to figure out angle C. And we talked about earlier how all three angles in a triangle add up to 180 degrees. And a right angle triangle is special because I already know one of them is 90, so the other two automatically have to add up to 90 because 90 plus 90 is 180. So to figure out angle C, all I have to do is 90, take away the angle I know, which is 35. So that should give me an angle of 55 degrees. And I do a double check. I now know the lengths of all three sides, and I know the size of all three angles. I've solved the triangle. Let's look at example B. Example B is a little bit different. It gives me two side lengths and no angles. If I look back at my list of options for solving, the only one that says to use two side lengths is Pythagorean theorem. So I have to go to my question B and use Pythagorean theorem to figure out the missing side. And if we remember Pythagorean theorem, the first thing I want to do is figure out where the hypotenuse is, because that tells me whether I'm going to add or subtract. Since I don't know what the hypotenuse is, I'm going to add because I want to find the longest side. So I've got to add and get a bigger number. So side squared, 8.6 squared, plus side squared, 9.4 squared, equals the hypotenuse squared, or we've also learned that we could call that side E because angle E is opposite. So equals E squared. And then we do our calculating. 8.6 squared plus 9.4 squared is 162.32. That's my e squared, my hypotenuse squared. And remember that the opposite of squaring is square root. And that should tell me my hypotenuse. About 12.7 centimeters. So now I know the lengths of all three sides. I still need to figure out all three angles. So when calculating an angle, I need two of them. Pick one and solve it. To calculate an angle, the only calculation of our three things that we can calculate an angle with when we don't know any other angles is SOHCAHTOA. So I'm going to look at my triangle and I'm going to label, I picked angle F. So 8.6 is opposite to F, and 9.4 would therefore be adjacent because the hypotenuse never changes. So opposite and adjacent is tan, SOHCAHTOA. So tan of angle F equals opposite 8.6 over adjacent 9.4. And if you recall from our trig review, to get an angle, we have to do the tan inverse of 8.6 divided by 9.4. And you can type that in your calculator. You can get a decimal and then do the tan inverse, or you can do it all in one step. I'm going to do it all in one step. So I'm going to do the tan inverse, and then I'm going to do my 8.6 divided by 9.4. And angle F should be about 42 degrees. And if I want to do the same thing I talked about earlier, trying to use the numbers you were given rather than numbers you were calculating, the numbers I'm given are 9.4 and 8.6. So if I want to figure out angle D, I would have to use trig again. Find angle D, 9.4 is opposite to angle D and adjacent. 8.6 is adjacent to angle D. So the opposite and adjacent change based on the angle you're calculating. So opposite and adjacent is still tan. So tan of angle D equals opposite 9.4 over adjacent 8.6. So angle D is the tan inverse of 9.4 divided by 8.6. Again, you can do your dividing first and then do your tan inverse, or you can do it all in one step. So when I do mine, I get that angle D is about 48 degrees, which should make sense because the two angles in a right angle triangle should add up to 90 degrees, because the third one is 90. And 90 plus 90 makes 180. And 42 and 48 are 90 degrees. So what you need to be sure of when solving triangles, make sure you calculate all the lengths and all the angles. Make sure you use the correct tool available to you. Pythagorean theorem, SOHCAHTOA, or what you know about angles in a triangle. In addition to straightforward solving triangle problems, sometimes we have a question like this. Some problems can be solved using two triangles. So if I look at my picture here, I have triangle A, B, D, and I have triangle A, D, C. And the red triangle and the blue triangle combine to make one large triangle, the green one. Sometimes you have to take one large triangle and divide it into two smaller right-angled triangles to calculate the length that you need. So you really have to be aware of the information, the numbers you need, and how you're going to solve it in order to figure out what to use. So if I want to determine the length of BD, that means I want to know the length from here to here, the base of my small blue triangle. If I want to find the base of my small blue triangle, I need to know some numbers other than one angle. Because we talked about earlier, to use Pythagorean theorem, you need to know the lengths of two sides. To use SOHCAHTOA, you need to know an angle and another side, or you need to know two side lengths. And to find an angle, you need to know two angles. So in my little blue triangle, all I know right now is 42 degrees. So I need to know another length. I'm thinking this will be a good length to figure out because that length is shared with the small red triangle. And the small red triangle has an angle labeled and a side labeled. And when I know an angle and a side, I can use SOHCAHTOA to calculate another angle or another side. So I'm going to use SOHCAHTOA to find AD, or I'm going to call it C because it's across from angle C. It's opposite angle C. So there's my angle C. Side C is opposite. And the number I'm given is on the hypotenuse, 17.8. Opposite and hypotenuse are sine. So sine of 67 is opposite C over 17.8. 17.8 times the sine of 67 is the length of the side I'm looking for. And let me get that calculated. 17.8 times sine of 67 is about 16.4, which makes sense because it should be smaller than the hypotenuse, which is 17.8. Lovely. Now I know that that side, C, is 16.4. And I know in my blue triangle that I have an angle of 42 degrees. So if I switch over to my blue triangle, 16.4 is still opposite to 42. And BD that I want to figure out is the adjacent side because it's beside 42. So opposite and adjacent, when I look at SOHCAHTOA, is tan. So the tan of 42 was the opposite, 16.4, over the adjacent side, BD. And from doing all the trig review you've been doing, you should know that when the unknown is on the bottom, it's a little bit different. Basically, when what you don't know is on the bottom, these two switch places. So you end up doing 16.4 divided by the tan of 42. And you should have reviewed already why that happens. And I get out my calculator, 16.4 divided by the tan of 42 is about 18.2 meters. So sometimes you've got to use information from one triangle to find information that you need to share to find what you want in a second triangle. So be very aware of what numbers you're given, where they are, and the information you need to use Pythagorean theorem, SOHCAHTOA, and the sum of an angle. Good luck with the questions. Page 15, number 9 to 14, I'll be around to check.